After that blog post went live, we got threatened with car bombing and arson. This is a hot end. There's no reason to murder anybody over a hot end. In hindsight, I wish we had handled some things differently. Unfortunately, I don't have a time machine.
All right, so welcome everyone. Today I'm interviewing the CEO of Slice Engineering, Dan Barousse. Did I pronounce that right?
You did, yeah. You actually got the French name right, which is great.
My girlfriend loves French, so I'm always having to practice my pronunciation. Um, but anyways, we got Dan here to kind of share some insights about slice engineering, patent law, and the 3D printing industry and technology in general. So glad to have you on the show.
Thanks for having me, Nathan.
Just to kind of make you a little more relatable, how did you get into 3D printing, and like what kind of 3D printers do you run in your own time?
Sure. So mechanical engineering is my background.
Uh,
And so I was working at a medical device company, day job. And then in the evenings, I was doing some consulting. I did some design work for knife manufacturers.
oh, cool.
So I have these old prototype knives that are in my desk. So yeah, I just I had friends and family that wanted to come up with something or like launch a new product, and that's what I used the 3D printer for. It was a tool basically for me to practice engineering and get the sort of iterative creative process moving faster. I started with a CraftBot 2 Plus, I think is what it was.
So I just looked up the CraftBot too. It
Yeah.
looks like kind of like an Ultimaker kind of box.
Yeah, similar. It's a desktop machine, open air, um, has side panels on it, but no top or front.
How did you go from having your first 3D printer to thinking like, hey, there's probably some way to improve this, and getting to where you are now where you're making kind of top end 3D printer accessories?
Probably every engineer using 3D printers at the time was thinking, how can I make this a little bit better and easier because of the number of failed prints and heat creep issues and material compatibility. And there were just a lot of pretty significant limitations on what you could and couldn't do with the technology. And my co-founder Chris is a huge part of this story because I did not come up with the idea. He wanted to print some peak uh, jigs basically for our manufacturing floor, and nobody could do it. We actually had a consulting call with E3D to see if they could help us do it, and they couldn't. Uh, so he decided, all right, well, it's just a thermoplastic. It can't be that hard to figure out how to print this. And a couple of years later, worth of prototyping and experimenting, we launched the Mosquito Hotend, which was the first sort of independent setup that could do both those high temperature polymers and then also the handle PLA.
What's the timeline of that look like? Like how long ago was this? Your introduction to 3D printing to releasing the Mosquito hot end?
Yeah, so I mean, I used 3D printing some in like in engineering school. Uh, 2011 to 2013 ish is when I kind of got that exposure, and then started using it at work probably 2015, 2016 genesis of the idea. That's when Chris was like, hey, we could build a better hot end. And then 2018 we launched the company at Murph. Actually, you mentioned a little bit ago that you were going to the Midwest Rough Rap Festival this weekend, and yes, we launched the Mosquito and Slice as a company really at Murph in 2018.
So that must have been a wild ride. I mean, 2018 really isn't that long ago.
No, it's not. It's not that long ago. Yeah, and it was. We've bootstrapped this whole thing, so it was just like my life savings and Chris's. Working out of a garage. He had a mill in his garage, so he was making prototypes, and I was actually using my living room as like a staging and packaging area, which my wife was not super fond of. But thankfully, we moved it out of the living room pretty quickly. Um, yeah, so it was all very, very grassroots and not that long ago, really.
So the first hot end on the printer that I had was called the Ubis hot end. And as far as I can tell, it doesn't look like it has a heat break. Like it's all just kind of one
Yeah.
conglomerated thing.
So a lot of the early hot ends had like a wood um, part of the frame was like a wooden piece, which is a terrible heat sink. But yeah, anyway, yeah. Sorry, Ubis. You were talking about Ubis.
Oh yeah, I mean, it looks like instead of wood they were using plastic, but same idea. It's like there wasn't a whole lot of thought put into the way that heat flows throughout the design. It's just like heat it up and squish it out. And I always had trouble getting that to print correctly.
Mhm.
And I'm guessing that's
Unsurprisingly.
yeah, I'm guessing that's because of the limitations of the hot end design they were using. Like extruders really haven't changed that much, other than like getting dual gears and stuff in the last 10 or so years. But
Although
uh,
Stratasys had dual gears from the beginning. So it was really just the desktop machines that didn't have dual gears until basically Bontech kind of reintroduced that concept. There's a lot of things that were done sort of early 90s on the super expensive like industrial side when 3D printing was not super accessible,
yeah,
and then have been reintroduced in a new form um, on the desktop scene more recently.
I mean, I probably the first printer that I ever ran was a Stratasys machine, and it costs hundreds of dollars to make a single part just because of the material cartridges have RFID chips and the service contracts and all that kind of stuff. And the prints weren't guaranteed to succeed either.
Yeah, right. Not very reliable and super expensive. It's not the best combo. You can see why it took a while to adopt the technology.
Yeah, and at the same time, I was running. I had some experience in our university robotics club where a couple of people had built 3D printers, and I bought one around that time that had that Ubis hot end. But I there was always constant issues with the stuff, and I didn't really fully understand how the 3D printer was working until I really reintroduced myself to 3D printing much later. And fortunately, things had evolved a lot. And like I just got an Ender 3 and started making awesome prints, and I was like, wow, this is crazy.
It's amazing how much it's evolved in really a very short period of time, all things considered. If you think about other manufacturing technologies like, CNC machining has its roots in like original wood lathes that were all foot pedal driven, and that technology's been around for hundreds and hundreds of years. 3D printing has gotten a lot better in the last 10, 20 years and will continue to improve even more so in the next 10 to 20 years.
So I think a big part of what makes your product different than other hot ends on the market is your control over the temperature gradient going from the stock plastic, which is basically ambient temperature or room temperature, and transitioning into the hot end. So what's kind of some of the physics going on is, and why does having a short transition from cool to hot make your print quality better?
Yeah, that's a great question. So, actually, I've got a little slide that maybe we can flash up on screen. Essentially, as you mentioned, plastic starts out solid, unlike a a more something that maybe we learn about in basic physics, like water, just transitions immediately at 0 degrees Celsius, basically from solid to liquid. There's no in between state. Plastic doesn't do that. It has what's called the glass transition temperature, and it sort of becomes like you know, like a noodle, right? Like a baked noodle. And at that point, it's not very good at responding to inputs. Like it's hard to, you can't push on one end of a wet noodle and make the other end behave like you want to, like you can on a solid rod, right? And so the shorter period of time that that the plastic can be in that noodly state, as opposed to full liquid or full solid, liquid's easier to control too, right? You just put pressure on it and it flows, but the noodle is hard to control. So if you can transition really rapidly from the solid to the liquid, it improves resolution. You can run higher temperatures without risk of carbonizing the plastic. There's all kinds of interesting things that can happen there, and that's part of what allows us to process these really high temperature materials like PEEK. But one of the ways that we do that is by making a really, really efficient heat break. So we invented the bimetallic heat break concept or a bimetal heat break. Stefan Herman, CNC Kitchen, did a really great video on that a while back where he talked about the bimetal heat break. And it's essentially a copper piece in the bottom, hardened tube in the center that has relatively low thermal conductivity, and then a copper piece in the top. And so as the filament comes down and it's solid, the copper in the top is pulling whatever heat does come up the filament path out, right? So it's acting as a better heat sink than the polymer is, and then it hits that heat break zone uh, where the conductivity is really low of the tube, and so not much heat is penetrating into that space. And then once it passes that, it's in the a new conductive space where you're transferring a lot of heat into the plastic very quickly. So it improves melt rate as well. And you get a more uniform melting rate across the radially across the filament also. So there's quite a bit of physics that goes into it, but the basic idea is we're trying to keep heat where we want it in the melted part, in the liquid part, and remove as much heat as possible from the solid part so we spend very little time in the gooey state.
And I hadn't really thought about it until now, but you mentioned, there's that transition from going from a solid into a liquid, and something that you learn about in like a material science or chemistry class is the phase change energy. So I assume it hits a certain temperature where it's like, okay, now I'm liquefying, and it kind of levels out the temperature for a little bit, and then starts to increase when it's fully melted.
Yeah, so there's kind of a funny um, the phase change diagram looks different than like water, for example, as mentioned earlier, but it does hit a spot where the temperature is not changing linearly with the temperature of the material is not changing linearly with the addition of more energy. If that makes sense, right?
Hmm.
Because you're actually absorbing you're taking the thermal energy and absorbing it as chemical energy to change the bond structure. Um, yeah, so the polymer chains are actually sort of disassociating uh, to turn into a liquid so they can flow freely.
Yeah, I mean, there's a lot of interesting thermodynamic stuff going on in there. It's
There
kind
is,
of mind-boggling.
yeah, and a lot of
Um,
material science too, which I'm not a material scientist, but we work with a lot of really smart folks that are.
you mentioned that having a shorter transition from cold to hot is beneficial. Isn't also having a smaller like melt zone, wouldn't that be beneficial as well in terms of getting better control, or is there some kind of trade-off there?
Yeah, so there's a trade off for a smaller melt zone um, does help you need less back pressure, right, to print accurately and to not affect resolution. But a longer melt zone also gives you higher total throughput because you have more uh, contact between the heated element, a hot block, and the plastic. And so the more you can increase that contact surface, the more energy you can impart to the material, and therefore the more you can melt and get out of the nozzle faster. And so there is a balance between having a really long melt zone and losing resolution and not being able to retract uh, accurately, and having a large enough melt zone to where you're hitting your time targets essentially of how fast you want to be able to print the part.
That's something I've noticed with some of my larger printers. I put like a larger melt zone hot end on there, and I'll even turn the temperature up beyond the typical printing temperature. And it works great when you're going along steady state, but when it pauses to retract and move somewhere else, then all of a sudden that filament is getting up to the actual temperature of the hot end, and it starts to kind of degrade a little bit. I can see little bubbles forming in the filament, and when it picks back up, the filament is too liquidy and it's not getting good print quality because of that.
Right. Yeah, absolutely. Yeah, there's a trade-off between again that increased temperature is if you're printing fast and the let's say you're printing PLA at 260 or something, right, higher than you would normally. Uh, the plastic exiting the nozzle is probably not actually at 260 if you're printing fast, which is something that I think people miss a lot.
Like if you're printing at 1 millimeter a second or whatever, just like really slow, um, 1 cubic millimeter a second, just like a really slow flow rate, that you'll probably get up to the temperature of the nozzle as you're printing. But if you bump that up to like 50 cubic millimeters per second, then it's just zipping through there so fast that it doesn't have time to actually reach the equilibrium temperature. So I almost think that it would be better to have like a slicer where you slice up the model, and it can transition between being in a high flow regime and a high precision regime. Like halfway through the layer, it'll be like, okay, now that I'm done printing all this fast stuff, let's cool off and do the fine resolution stuff. So, I mean, there's a lot of optimization you can do in the slicer that I feel like there just really hasn't been much innovation in, at least from what I've been able to see.
Yeah, I agree with you 100%. It's a kind of a twofold problem, right? There's some hardware elements that you can improve from the mechanical design standpoint. And then there's also the software side where, yeah, if you had better uh, or I guess more variable temperature control inputs, right, during the print, then absolutely you could, all right, we're going to come to a spot, we're going to have a lot of overhangs or something. All right, we're going to bring the temperature down, bring the speed down. Like the slicers are adjusting speed right now, but they're not using temperature as a variable throughout the print. Uh, and that's a huge opportunity for optimization.
I wonder if, a lot of these slicers are open source. So I kind of want to get into the open source versus closed source and patentable uh, topic, because that's something that I think has put slice in a little bit of hot water sometimes with the community, rightfully so or not. I mean, it's definitely been an issue for you guys. I mean, part of the reason you were able to build your company out was that you had the patent protection for your hot end, so you can market it and invest a lot of money in it. Like you said, you're investing your life savings and stuff. Like you're really putting a lot of work into it. If you want to build a large company, you'll need to get investors involved. And if they see that, hey, they've got this great idea, but someone else can just take it and run with it, so why are we going to give them $1 million to develop this? I can definitely see an argument for IP being a really important part of your business model.
Yeah, not only for outside investors, so far we haven't taken on outside investment, but also for customers. We work a lot in on the industrial side of the space, and it is very difficult to land a customer that has patents or has patented technology if you don't. Right? It's almost like a notch on your belt. Like you can measure up. Um, it's also makes it much more risky to work with larger companies because I don't know if you're familiar with the story of the guy who invented the windshield wiper. So he, shows off his invention to Ford basically, and they tell him, get out of here, like shoo away. And then they go and put the windshield wiper on all their cars, and they're selling millions and millions of cars. Well, that would have totally changed this guy's life. Um, but he didn't get credit for it. And then Ford comes out with this new innovation that they invented. Um, but he doesn't get any credit, right? He's not compensated for his efforts. He gets ripped off. And so those types of cautionary tales are scary, and it's the reason that the patent laws exist in the first place. Obviously the system doesn't work perfectly. The first to admit that. I wish it were. There's a number of changes that could be made that would make it more accessible and maybe more fair. Uh, but the original intent of the patent office was enshrined in the Constitution, and it talks about protecting inventors so that they can, profit off their ideas and make the world a better place. Right at the end of the day, uh, yeah, making money is important because you got to pay your rent and you got to feed yourself and all that. But people exist for more than food and paying the mortgage, right? They want to do something bigger with life, and that's why I was doing printing stuff on the side, doing consulting work nights and weekends, because I felt like I had the opportunity to help somebody else bring their idea to life through using my skills, and that might make a dent somewhere in the universe, and that's a cool thing. And that's why we started this company, was because we want to help other people uh, that may not normally have access to bringing a product to market, to be able to bring a product to market and then print it reliably, or maybe help somebody scale a business. Or uh, one of our very first customers was a early stage medical device startup that just earlier this year created the world's first peak printed, FDM printed implantable cervical spacer. So you can get a customized graft that works for you if you need, cervical spinal surgery, and it's getting better patient outcomes and improving the lives of people. And it wouldn't have been possible without 3D printing. And they couldn't have launched their product if it hadn't been for our Magnum Plus Hotend technology. So we're like a very, very tiny cog in the bigger human creative endeavor, but it's something I'm proud that we're doing.
Yeah, and I think patent law and intellectual property in general is kind of a difficult subject
Yeah.
because I mean, I'm an engineer, you're an engineer. When I go into a meeting and we're talking about like, hey, what's the better system, this or that, like Bowden tube or direct drive or
Yeah.
copper heater block or aluminum heater block, like you can point at things and be like, well, this one's better because of this, and you can come up
Right.
with a list of pros and cons. When it comes to the patent system, that is like such a massive enterprise that's been it's a relatively recent thing that patents have become so important because like I say recent as in like the last 100 years or so.
Yeah. Yeah. The last couple 100 years. Yeah.
Yeah, but since the Industrial Revolution and manufacturing has become so centralized, um, someone who owns a factory can rip off other people's products very easily.
Very quickly. Yeah.
Versus before, it used to be that like, well, you'd have to like get the blueprints and then train a bunch of people to cobble these things out of basic materials by hand. But now, if you have a drawing for something, you can have it manufactured in 20 factories across the globe, basically overnight or within a week.
Yeah. I mean, if you and I were, you know, uh, furniture makers in medieval Europe, like, and you had a better furniture design and I was in the next town over, it would not be economically viable for you to more than likely transfer your furniture to another city. So I could go to another city and make the same style of furniture, and nobody would be the wiser because transportation costs and just people didn't travel that much, right? So in that sense, the patent wouldn't make that much sense, right? But once you're able to, let's fast forward that a couple 100 years, we're both furniture makers now, and we both have factories. Now, if I take your idea, not only can I maybe figure out a way to make it faster or cheaper because I didn't do any R&D work, right? Because you've basically funded my R&D, but now I can drive you out of business because I can come back into your town and take all your customers. So the intent of the patent system is to prevent uh, inventors from subsidizing everybody else's research and development, right? It gives you a temporary, time bound monopoly on your idea so that you can make enough profit off of it to recoup your investment. And then the idea is in the public domain, right? So then after that, everybody can go make the same thing, right? That's how patents work. 20 years is a long time.
Right. I
Now,
was going to ask, like, is
yeah.
there anything that you would change about patents, whether it's the time frame or like the filing method, or
Hmm.
is there? Do you think there's ways to make it more fair?
I do. So there are, different industries take different amounts of time to develop something. So say you're trying to launch something that is, in the pharmaceutical industry. Well, it's going to cost you $1 billion in probably 20 years to develop this. So if it costs you $1 billion in 20 years, a 20-year patent, that makes sense, right? Because it's literally 20 years, 20 years.
Right.
And the cost is so high, so you need a really high barrier to entry to make it worth the investment, or else nobody would invest 20 years and $1 billion to do it, and science would not continue to move forward. Uh, there are other things in other industries where maybe it takes 3 years to develop something, or 1 year, maybe it's 6 months to develop an idea and commercialize it.
Right. Especially with like additive manufacturing, we're shortening those development time frames
We are, yeah,
with mechanical design and electrical design now.
right. And even just the accessibility of CAD tools, right? And um, quick turn manufacturing and the accessibility of CNC, like all injection molding even getting cheaper, metal injection molding. Like there's all these manufacturing technologies that are moving forward. So yeah, there I think are industries where it doesn't make sense to have as long of a patent. I'll say that with a grain of salt, because in order to shorten the patent timeline that it's granted for, you should also shorten the amount of time that it takes to get a patent. I'll give an example from like Germany, for example. It takes 5 years to get a patent granted in Germany on average, right? So it could be 7, could be 4, but typically 5 years. So think about, if you invented something, you can either bring it to market and risk, your competitor basically using you as subsidized R&D funding, or you can sit on your invention for 5 years, and by that point, maybe the market has moved on. And so, what we've seen in Germany is that the number of patents being granted to individual inventors has just totally fallen off a cliff. Um, that is occurring in the United States to a lesser extent, but in Germany, it's really, really bad. So, only huge companies like BMW or Porsche, like those are the companies that are filing patents because they have the resources and the time horizon to be able to make it work.
So the other thing about patents that kind of limits its usefulness is they're only enforceable within a certain country's laws. Like if you have a patent for something in the US, then someone in China or even France or Germany could produce an identical good. And since you only filed the patent in the United States, then they can go ahead and make it, which almost puts domestic competitors at a disadvantage compared to competitors abroad.
Yeah, enormously so. Yeah, and that's true. If you're in Sweden, creating something and then you're trying to sell into the U.S. market, it's not cheap to get a patent in the U.S. And with exchange rates constantly fluctuating, like that becomes more expensive, and you ideally have a lawyer in that country who can help you navigate the system because the language is different, blah, blah, blah. Like the number of variables that increase the costs add up really quickly. So yeah, in an ideal world, there would be kind of a unified patent law that was global. Now, there is something called um, the WIPO. So it's anyway. There's a world patent treaty that was signed by most industrialized nations.
Can I guess the people who didn't sign it?
There's a few countries. Anybody who wants to look at the list, feel free to do that. It's called the PCT, the Patent Cooperation Treaty. And then WIPO is like the organization that kind of works within the PCT. So, yeah, so there are countries that didn't sign it because they didn't feel like it was in their best interest.
If the only participants in the patent system are your domestic competition and anyone wanting to sell into your domestic market, it kind of relies on your market being the most important.
Yeah.
What I didn't really understand about patents at first is that it's actually it's like a monopoly, and you said it up front, which is good, but maybe it's not in the best interest of a country to basically put everybody else in the industry at a disadvantage because of the inventions of one company. And then also, like, nobody can force you to license your patent to someone else. Whereas in other countries, I hear they have laws where the government can just take your patent and be like, hey, everybody can have this, or they can force you to sell it at some predetermined price. I'm not sure how they come up with the price, but that's something that I've heard of.
I'm not familiar with those particular rules. I'm pretty familiar with U.S. law. I don't know, I'm an American, so it would seem pretty crazy to me as an American who's used to like individual freedoms and liberties and stuff for the government to come and say, "Hey, we now own your intellectual property, your ideas," right?
Mm-hmm.
That seems very crazy, but
Right.
it's certainly not without precedent.
Yeah, and there's also like you brought up pharmaceuticals, so like I think some areas where it gets into a bit of a moral dilemma is like if you develop a drug like a pharmaceutical that could save someone's life, but it's overly expensive because you have a government provided monopoly, then should you be forced or subsidized? I mean, I don't think anyone would complain if the government would just come in and say, "Hey, however much you want us to buy it for from you to give to people, we'll pay it. Like we see that people need this invention and you own it, so we're going to have to pay you for it."
I mean, that's what insurance does, right? That's what health insurance does essentially, is they bargain prices for uh, large purchases of different medications, and then because they have the bargaining power to negotiate down the price as a large buyer, right? As opposed to you and I trying to get a prescription, like we were going to go to Mayer or something, or excuse me, Bayer, and be like, "Hey, I want whatever drug." They're gonna be like, "Sorry, bro, like we don't sell you one pill," you know. Uh, but insurance can make those sorts of negotiations. I'm not saying the system's perfect.
Right, right. It's ideally everyone would be able to have those medicines and innovations, but they might not exist without the financial incentive. Is
Right, there has to be financial incentive to develop new stuff.
I like the idea of government funded research, like a lot of stuff that we enjoy nowadays, like GPS and robotics developments, have come from government funded research, and that's kind of like the other way that governments can produce technology that everyone can benefit from. But then it comes to the like when it comes to allocating a huge pot of money and figuring out which research projects are going to be worth funding, there can be a lot of waste. Versus in the patent system, people are putting up their own money to make the developments, so they can produce more targeted solutions, I think.
I mean, a lot of government funded research also ends up in patents. They're just patents that are owned by the government, and then they can uh, license those things out to companies like the GPS example developed by the U.S. Army, but the U.S. Army didn't commercialize it. Like they're not in the business of making a commercial product. There were other companies that then went and commercialized the back end systems and the servers and the satellites. Like there's all these companies that commercialize that to make it accessible and financially feasible for everybody to have it on their smartphone.
So the other, I guess, like when it comes to the kind of the moral arguments against patents and why like a government might want to step in and take control over certain ideas. Another one would be like if you have a defense contractor that develops a technology and then patents it, like let's just say uh, Lockheed Martin or something. They
Hmm.
come up with like some groundbreaking new technology that will allow them to target missiles or whatever much more effectively. If they're holding their technology behind like an extremely expensive licensing regime, then to the point where the government isn't able to procure things that would help in the best interests of like national defense. I wonder if there would be cases where the government would be like, well, hey, we're actually going to take that patent because we really need it. Like,
Yeah, but who's going to build it? I guess then, right? Like Lockheed's the one making the weapons.
you'd burn a lot of bridges that way because then it's
Yeah,
like,
you
well,
would.
why do I want to contract with you anymore? I might as well be designing tractors or something instead of.
Right. Yeah, you get into um, individual property rights, which is the if you really want to go back, you can read like John Locke, um, and you can go as far back as like Aristotle and Plato talked about individual human rights and property rights and the importance of property rights. And um, the writers of the Constitution talked a lot about property rights uh, and no taxation without representation, right? So
Mhm.
property rights extend to intellectual property. That's why the name is there, and that basically says, okay, I if I come up with an idea, I own my idea.
Right.
Um, and
There's
so
so many great like counterpoints to both sides of the argument, and I
there
think the
are
reason why that is because lawyers have been involved for decades.
not just
Lawyers,
lawyers, philosophers too, right?
yeah,
Like Marx wrote anti John Locke papers, and um, uh, gosh, what's the name of the guy that wrote Adam Smith? He wrote the original treatise on macroeconomics. Um, so he writes a bunch of things that are very anti-Marxist, right? And so you get this. Yeah, I mean, there's arguments on both sides to be sure. What's fascinating to me about specifically in our space, the 3D printing space on the open source side, is obviously open source has a place. I think there's absolutely a balance between guaranteeing intellectual property and rewarding innovators, and also uh, creating things that are available for everybody without a license. What is interesting about that is that for some reason people draw a major distinction between patents and copyrights and trademarks. So people seem to be okay with copyrights and trademarks, but not okay with patents.
As a content creator, copyright's important for me because someone
Right.
could just be, put a screen recorder on my videos and just re-upload them and
Exactly.
compile hundreds of YouTubers' best content into a single channel.
Yeah, totally.
So I get that there's a like a bit of hypocrisy for anyone who's on YouTube saying that patents shouldn't be allowed. But also, like, you could make like the argument that uh, I think there's a distinction between like physical property and intellectual property in the sense that physical property, like if I have my phone and you take
Mhm.
it away from me, then I don't have my phone anymore. Versus if you have your blueprints to the Mosquito Magnum and I take the blueprints, then you still have your Mosquito and you can still produce it, but so can I.
Yeah.
I think Thomas Jefferson said that it's like lighting someone else's candle. He used a different word for it because he was old like that. But
Right. Yeah.
it's like if you have an unlit candle and someone comes and lights your candle, then you don't
Right.
lose your original flame. You've spread it around.
Yeah. So that I guess the way you've used that analogy is very positive, in the sense that it's assuming that lighting somebody else's candle causes no detriment to the person who lit the candle. Fire is relying on the fuel from both candles, right? A market is,
Yeah, the whole market is like a fuel, right?
yeah,
Yeah.
yeah, the whole market is the fuel. So it would be more like, uh, if you had a can of gasoline or something and you light it from two sides as opposed to lighting it from one. Like, how fast does the fuel get consumed? I mean, I guess that's still a terrible example because the flame fronts would merge and you'd end up with one flame. But I guess burning the fuel twice as fast, right?
Mhm.
But you're burning from the same source because the market is the source. It's not uh, your manufacturing plant or whatever.
Um, yeah, and I think this ties into the idea that we're sold when we buy a 3D printer of we can make whatever we want, and I think patents can get in the way of that. Like if you wanted to print something that's patented, then or something that's copyrighted,
Hmm.
then you wouldn't necessarily be allowed to do that. Like online, people are selling CAD models. Like I have some of my models behind a paywall just because I put hours and hours of development into it, and I have my own
Right.
expertise that is used to produce those,
Hmm.
and I have to get paid somehow to keep this whole operation going. So
Right. Exactly. To be sustainable, right? For you to be able to pay the mortgage and eat and continue to produce more stuff, you have to get remunerated for it somehow.
right,
Um, yeah.
I just quit my job recently and have been doing this full time, and I'm like, oh crap,
Congratulations.
the money's got to come from somewhere. So
Yeah.
I'm like looking around. It's real nice having a stable job to fall back on. But I'm giving it a shot for a year. I think it'll
Yeah.
be I'll be able to make it a year. And if it doesn't work out, then I'll just go back to work in a 9 to 5.
Well, I'm sure you can make it, Nathan. Whether you think you can or you think you can't, you're right. Right. It's like,
So instead of these kind of heady intellectual examples, do you think we can talk about something a little more practical, like
sure.
some of the patent cases that you've been involved in, whether that's with other hot end manufacturers or 3D printer manufacturers?
Sure. Yeah. Do you have a specific question you want to hit?
Yeah, so I mean, mainly, I've there's the whole controversy with Vez and the Goliath hot end.
Hmm.
Also, there's other companies that are producing similar products that might be infringing. I think Fadis and Triangle Labs and several of the Chinese manufacturers are also kind of in what do you call it? The legal litigation with.
Yeah. So we're not in litigation with anyone. Um, Litigation refers to this is something that we've been accused of suing a lot of people. We've never sued somebody. I'm not saying we never will, but it'd have to be pretty. It'd have to be a really good case for it, right? And we would much rather try to work with somebody than try and sue them. So we've never sued anybody. So just let's put that out there. People for some reason think that like uh, sending a letter, like a cease and desist, for example, is equal to a lawsuit. It's definitely not the case. When you receive a cease and desist, you're not being summoned to court, right?
So
Um,
I've heard that when you get a cease and desist, if you don't think they have a case, then you just keep on going with your business, right? Is that kind of how it goes?
uh, yeah, I mean, what I would say is if you ever receive a cease and desist, you should probably seek legal counsel, right? Um, it would be, I think, unwise and uh, highly risky from a business standpoint to just ignore the cease and desist. I mean, for example, if you were producing content and you got a cease and desist from another content creator that said, "Hey, you ripped off my content," like you should probably not just ignore that. You should be like, "Hey, maybe I should talk to this person. Maybe I should get some legal advice," because it can be a really big deal. Um, so choosing to ignore that, I think, is probably not the right move.
Yeah, probably what I would do, and I'm not advising anyone else do this, is I would just blast them on YouTube with my platform. Just
Well, some
which
people certainly do that.
so you've sent a couple of companies cease and desist, and that's kind of based on, I guess, your patents over the Mosquito Magnum or one of your mosquito products.
Yes, we have a number of patents, uh, and we have sent cease and desist letters where we felt like the other company was, infringing on our intellectual property. The companies that we have sent them to are a lot of times not only copying the design, but they're also, or the intent of the design, but frequently also taking copyrighted stuff off our website, also taking our images. And when Fadis first launched their website, I'll name that name at least, uh, they took the copy that I wrote on our product descriptions and they took the diagrams that I made very poorly, but still made them. um, I think I made those in PowerPoint originally or Excel, and they took the pictures that my co-founder Chris had taken with his camera, and they put them all on their website to promote their product. Uh, so if anybody is thinking that it's just about patents, like it's about all of the above. It's about copy pasting somebody's life's work and selling it as your own. Um, that's not okay.
So, what product was that in reference to? Did they have a mosquito clone, or was it more like the Dragon Hot End?
That was
Or
the Dragon. Yeah.
okay,
Mellow did the same thing with their NF Crazy hot end, right? In fact, the original NF Crazy, I think, was called um, something crazy mosquito clone. Like it literally had mosquito clone in the name. It's like, okay, thanks, guys.
yeah.
Uh, so then they're taking our trademark, and they had our images and some of our copyrighted stuff, and that was what basically comprised the listing of their product on AliExpress. So that's pretty frustrating.
So, based on those infringements, are they able to sell that product in like China, Japan, uh, EU, based on like, are they legally allowed to do that, or is it just the U.S. market that is kind of being controlled by the patent?
I'll make a general statement. A patent is enforceable in the territory in which it has been granted, right? So, uh, yeah. So I guess I'll just leave it at that. I think that's clear enough.
Okay, yeah, we don't need you on record saying anything that'll get you in trouble. Well, I just want to say that that's kind of the issue with patents, I think, is that you're disclosing all of this information that someone else can just take and use in a market, and unless you're going to get it patented in every single market around the world, which basically only Fortune 500 companies have the money and resources to do,
Mm-hmm.
then I think you're always going to be at a disadvantage by disclosing it. by disclosing exactly what's going on. And with physical products, you disclose exactly how it's built by selling it, because someone can just take it apart once they get
Right.
it.
They can just take it apart. Yeah. Yeah. So, in my opinion, properly, the only way to have any sort of protection around designing a physical product is to have patents. Because even if you're only, let's go back to the fuel analogy with the market, right? Even if you're able to sort of block off a little bit of fuel for yourself in one
Mhm.
market, right? Let's say the United States, uh, it is more sustainable as a company to be able to keep fueling further innovations by doing that than it is to just not have any protection at all. Yeah,
Yeah, and the product development lifecycle is something that's very long. Like
it is long. Yeah.
I've been involved with a lot of stuff in my professional career, and also I have this modder board that I produce.
Hmm.
Um, and I realize that someone could just, reverse engineer it and produce their own version.
Yeah, very quickly. Yeah.
My form of intellectual property protection is that it's not really worth it for someone else to do, because I already sunk enough time into it, and it's not that big of a market. But
Right.
with something like a Hotend that can unlock different material capabilities, I think that's something that's worth paying for to a lot of companies.
That's essentially what allows us to continue as a company is that we work with a lot of companies and they are willing to pay a price premium for quality and support and increased performance, right? uh, Dragon hot ends don't perform as well as ours do. So it's the question of, okay, do you want to buy something over and over again, or do you want to buy something once that's going to last for a really long time and have US support behind it? And I don't want to have our entire conversation be about IP because that's really not what we're about. Like IP is a very small piece of one of the ways that we do things as a company, but it's not really why we exist or why we come to work every day. I'm not like, hey, let's go make more patents. I'm like, hey, let's go help some people.
I'm
Uh,
feeling like I could go for a patent right now. I mean, I come up with a lot of ideas and I just
yeah,
put them on the internet. I think that there's definitely that's pretty much the only way to make a sustainable living as an inventor.
yeah, it is
Anything that I produce will just get ripped off if it doesn't have some form of
ripped off
protection.
immediately. Yeah, I'll give one more example of this. We ran a Kickstarter for our Copperhead hot end when we launched it, which is a fully open source product. We have the full manufacturing drawings online. We used that product to open source the bimetallic heatbreak technology that we developed in the Mosquito. So anyway, fully open source thing. It's part of our hybrid model, uh, where we open source some things and we patent other things so that we can again keep the business sustainable. But when we were doing the research to run that campaign, I ran across a guy who had run a Kickstarter campaign and he invented the hoverboard things, like the two-wheeled hoverboard. So he ran a successful Kickstarter campaign. But by the time he started taking delivery of the actual product and started shipping them to customers, there were so many companies that had already reverse engineered his thing and started selling them to Walmart, Amazon, etc., all over the place that he went out of business. He lost his shirt, like literally lost everything. Um, and yeah, and it's because these companies that reverse engineered it were able to. He disclosed enough in the Kickstarter campaign that they figured out how they could make it. Maybe it's not to the same quality as what he was doing, but it was enough to be able to launch the product quickly. There was enough demand out there that he lost everything.
And only a few hundred houses had to burn down from battery fires as a
Probably
result.
right. Yeah, exactly. But who are you going to call? Like when that happens, right? There's nobody to sue. There's nobody to call. There's no tech support. There's nothing. Yeah.
Yeah, I definitely think that there's an issue with it not being a fair playing field when you've got like other countries selling products that have completely different standards for environmental protections, workers' rights, and all that kind of stuff. And in my opinion, I don't want to get into a whole economics thing, but like if you're having to compete with companies that don't have to follow the same rules that you do, the only way to, I mean, one of the ways to balance the playing field would be to slap massive tariffs on everything that's imported. But
We
other
did
than
that
that,
with our last president.
before we move on from the IP stuff, is there anything you want to comment on with like the Vez situation? Because
Yeah. Thank you for bringing that up. We kind of got sidetracked. Yeah. So I'll say this: I like Simon personally. I think he's a good guy. I think he's a good designer. We verbally offered him a design job at Slice before all this stuff went down. Um, in hindsight, I wish we had handled some things differently. Unfortunately, I can't go. I don't have a time machine. Uh, Simon himself has admitted that the first version of the Goliath did utilize our patent. Um, he has also gone on record defending us a couple times after he uh, said that AliExpress had taken down the Mellow listing for the Goliath when it first launched or tried to launch. We got death threats. I was people threatened my family. There was a whole plot to assault me at Formnext in Germany. Thankfully, that didn't happen. I wrote a blog post that was very inflammatory, which, again, in hindsight, I wish I had said things differently. But, once you can't retract words, unfortunately. After that blog post went live, we got threatened with car bombing and arson. I had a police officer watching my house for a long time. We were in touch with the FBI. Like, it got very serious very quickly. And to Simon's credit, when he found out that stuff was happening, he very much tried to like, hey guys, chill out. Like, this is a hot end. There's no reason to murder anybody over a hot end. Like,
yeah,
let's try and reset the expectations here. So at the time, he was an affiliate of ours, and we were advised by our FBI contacts, and we had to hire a PR firm, and by our PR firm not to continue conversations with him. We kept paying him affiliate commissions until he requested to, I think he may have had like a moral dilemma there where he's like, okay, I'm not, I don't want to be making a commission off of people that I'm competing with. So I appreciate that. He requested to be removed from the list, and we honored that immediately. I would like to reestablish communication with him now that things have died down a bit and nobody is threatening to kill me. So anyway, that's something that we'll be working on in the near future.
yeah. And what specifically is patented about like? I think it's the spacers, the spacer technology that you guys use is the main thing. I mean,
Yeah.
some people say like, oh, that's obvious or trivial or
Mhm.
whatever. But what
Yeah,
would you say to people who have that belief?
sure. So there are a couple of tests that a patent has to pass or patent application has to pass in order to be granted. First one is obviousness, and then the second one is novelty. Um, and there's a third that I'm blanking on off the top of my head, but
Oh, it has to have industrial application or something like that.
yeah, it has to be not industrial necessarily. There's like an actual legal term for this, but yeah, it has to be usefulness. That's what it is. It's the novelty test, the usefulness test, and um, the obviousness test. So we passed all of those tests. Obviously, there were no hot ends that looked like ours and left the heat break not under a load. Right. Basically, the structure allows for the heat break not to be under any load.
Yeah, you've got two competing like requirements there. It has to be strong enough that if it runs into something, it's not going to snap off, but also has to be thin enough that it's not transferring too much heat.
Exactly. Yeah. So there were other hot ends that had a structure, right? Like the famous Creality hot end. There's been millions of those produced. It has the two screws on the side, but that heat break is still under load. Like
Yeah,
it's in a compressive load. And so we built a hot end that the heat break wasn't under any load. And that's essentially what the patent is around. And nobody had done that before. If they had, then there would have been nothing for us to design because the problem would have been solved.
Yeah.
And if we hadn't solved that problem, then Mello, Fadus, Triangle Lab wouldn't have made millions of dollars off of selling versions of our product. That's just the reality.
Yeah. So, well, I think that should be the final nail on the coffin for the IP debate. Like, I think there's a lot of other stuff going on in slice engineering. So, what does like a typical day of engineering look like at Slice? I mean, you obviously have a lot of thermal analysis that goes on. So I
Mm-hmm.
took a thermodynamics class. We've got like the lumped mass models and the finite element kind of analysis for
Mm-hmm.
heat transfer. Are those tools that you use on a regular basis?
So I'll say this: I'm not doing much engineering anymore. In fact, I do hardly any engineering anymore.
Uh,
Um, my engineering personally is more like high level strategic type stuff. Chris, my co-founder, is still very much in the weeds with all this, and the rest of our engineering staff is very much in the weeds with this. But we use some simulation stuff, including FEA, uh, not so much on the thermodynamic side, but more so on the mechanical side. And then we do a lot of like we have test rigs that we build where we're collecting a lot of empirical data. We use a lot of thermal tools that like thermal cameras to it's still collecting empirical data, but it's visual. Obviously, you can sort of see where the heat is flowing and the effect of making certain changes. We use SolidWorks and Fusion, and we have a few different models of thermal cameras from various companies and lots of sensors. And we're building custom electronics stuff on breadboards and using Arduino and basically normal engineering tools. Yeah, so we're doing all very normal engineering stuff here all the time.
So how about the new Mosquito Prime Hotend? I
Mm-hmm.
assume you had to develop some new testing methods for that thing just because it's got a lot going on there. Well,
Yeah,
not necessarily a lot going on, but it's at least twice as much as a normal hotend.
yeah, yeah. So for the Prime, we basically built on what we'd done with the Magnum Plus. We launched the Magnum Plus in 2021, and we actually developed them sort of in parallel, and Prime just took a lot longer to get across the finish line. But the idea behind Prime is we want to increase the flow rate as much as possible, especially with harder to print materials like a TPU, for example, without massively increasing the total print head size. So it's intended to be used on larger format machines in industrial type applications. A lot of the requests that we've had for something like this have been from people that are printing TPU. So we did a lot of testing with TPU. A lot of the focus was around the total melt zone length as well as amount of heating power, where you put sensors to make sure that you're getting the as close as possible to the actual temperature of the exiting plastic. Like a lot of the hot ends on the market don't isolate the sensor from the heater. And so the sensor picks up the temperature of the heater,
Right.
but not necessarily the temperature of the plastic.
Yeah.
But what you really care about is the temperature of the plastic, especially if you have an application, we call it like a mission critical application where you need certain mechanical performance from the end use part. I talked about Curativa, the spinal, cervical spinal graft earlier. So like those folks, if they didn't have the right mechanical properties coming out from because the polymer was the wrong temperature when it was exiting, and you're not getting the interlayer bond strength that you're supposed to because the cross-linking only occurs at certain temperatures, and there's formulas and linear regressions for that. If that's not occurring, then you might have a failure in somebody's neck, which is kind of a big deal. Like you
Yeah.
need your neck to support your head, and so that's really where this makes a lot of difference is where we're looking at, all right, what are the final mechanical properties of the printed part, making sure that we're getting the right interlayer bond strength because the plastic is exiting at a known temperature, and we are increasing the flow rate as much as we can while still doing it reliably. We've got a die in the center of the Prime that splits the flow path once the plastic is fully melted and creates a more laminar flow regime, and that speeds up the total output. Um, so that geometry took some time to figure out and figuring out where to put it. We took a lot of lessons from injection molding to make that happen. Yeah, so there's just a ton of research that went into figuring out how to make this work correctly.
I think I was talking to Peyton at the trade show, and he was
Mhm.
saying that the top hot end is overheated a little bit to kind of boost the heat transfer rate, and then when it
Mhm.
gets down to the lower portion of the hot end, it's a little bit cooler.
Yeah.
So, what kind of advantages do you get out of that kind of a setup?
Yeah, so that's an idea taken directly from injection molding. In injection molding, you will have multiple um, heat zones that are run at different temperatures as you run the plastic down the barrel. And you sort of preheat, just like we were talking about earlier, the plastic doesn't actually reach the full temperature that the controller has set it to, right? It's say you set it to 210 for PLA, it might actually be exiting the nozzle at 205 or 200, depending on how fast you're printing, maybe 195. And at that point, you do get a change in mechanical properties. So the prime can be set up with two temperature zones where you're basically not overheating, but you are increasing the temperature at the top end to impart more energy to the filament to allow it to melt faster and move faster through the melt zone. And then in the bottom section, we have a temperature sensor in the bottom section to more precisely control the actual exit temperature uh, as the plastic leaves the nozzle.
Okay. Yeah, so you're still, it seems like using conduction as the main form of introducing heat into
100%.
the
Yeah.
plastic.
Yeah.
Um, when I was doing I was just trying to do some brain exercises to see like, hey, how can we speed up printing even more than we already have? It
Mm-hmm.
seems like the bottleneck is that conduction from the metal part into the plastic itself, just because plastic is not a very good conductor of heat.
Right.
Have you done any experiments with volumetric heating of the plastic? That's something that I was interested in. I started looking at online to see if like, hey, maybe I could patent this. And it looks like Desktop Metal has like about 1,000 patents on
They have a lot.
everything that you could imagine to do. And it's like, are they even doing any of this, or are they just writing this down to get credit?
Yeah. Well, and I won't comment on their patent portfolio necessarily, except that they do have a lot.
And they got acquired, or they did some kind of merger with Stratasys. Is that
That's in process. I'm
okay?
not sure that it's. I don't think it's official. They're going to have to get clearance from the SEC and all that. But yeah,
Okay.
it's going to be. If they do merge, it's going to be kind of nuts. Like it'll be, they will become the biggest 3D printing company by a long shot. There's really only four kind of major players. Well, maybe five publicly traded.
And
Uh,
Stratasys
companies.
is the main one for FDM, right?
Right. They invented the FDM technology. Scott Crump was the guy who started Stratasys and invented the FDM technology back in the late 80s. So,
But I was thinking, ultrasonic heating, like you could just
mhm.
shake the plastic around in there and get it
Yeah.
internal friction to heat up, or like having metal particles inductively heated and all sorts of things that could be used. But it seems like Desktop Metal's got it pretty locked down. So it's
Well, I would say this is that uh, nothing is ever fully locked down. you know, inventors' ingenuity knows way fewer bounds than lawyers' ingenuity. Um, so I'm sure there is a way to do something in a new way that could add value, right? It just takes a lot of effort to figure out what is that way.
right.
And, there's nothing wrong with experimenting without commercializing a product, you know?
I think when I was working at other companies and I was like trying to come up with new ideas, they would say not to even look at other companies' patents
Mhm.
because just come up with what you come up with and let our legal team figure it out.
Right.
But you might end up reinventing something that someone else already invented, and then it's like, wouldn't that just be a waste of time?
We look at other people's patents when we're looking for there's a concept called freedom to operate, and there's another legal concept called a patentability analysis. And so you want to try and find green, again, my opinion, you want to try and find green space of where is a place where you can improve the state of the art uh, in such a way that it's adding value. Um, that should be the goal. I would say.
Yeah. And the whole patent system doesn't really work. It doesn't deliver what it promises to deliver in terms of having everything publicly disclosed so people can build on it if you're not actually going through there and looking at what's
Right.
out there.
Yeah.
It's like having a library and just locking it up and not
Yeah.
going.
And there's a whole section of like when you file a patent, you reference prior art, right? And there's a whole section at the beginning that's called like the background of the invention. And basically you are talking about what is the state of the art in the industry, and then you go into all right, what is different about our idea, so there's, I would say it certainly would make sense if you're trying to come up with some new way to do something to look at available patents already out there. Some of them could be expired, and then maybe nobody's commercialized that and you can bring it to market.
Well, what advice would you give to any, young engineers out there that might have an idea that they want to patent or bring to market? Like who's the first person they should call other than their mom?
Well, I'd say it's always a good idea to have a group of people that you can bounce ideas off of, because when you work in isolation, it can be, unless you're doing something that's very easily testable. Thomas Edison, as an example, right? He like invented the light bulb in isolation, but he knew exactly what he was trying to do, and he just was iteratively trying to figure out, okay, what is something that works? If you're trying to do something that's um, if you're thinking about the original idea, you're not to the point where you're like, all right, I need to find a way to I know what the light bulb is, or I know what I want it to be. I need to figure out how to make it work. If you're at the early idea where you're like, I've got an idea for, a light bulb and also, a fax machine and something else, like, uh, at that stage, you need to be talking to other creative people and running your ideas past them and being like, all right, is this a good idea? Is this a terrible idea? Do you think there's a market for this?
Yeah. What if they stab you in the back and steal your idea before you patent it?
Yeah, I mean, that is a risk. Just like there's always a risk if you love somebody, they're going to break your heart.
Yeah.
Yeah, say make sure you do it with people you trust. um, yeah. So if you've run an idea past somebody, at that point, I'd say use 3D printing to try to prototype quickly, because the faster you can iterate, the better and the more iterations you can go through, the better your idea is going to be. And then I'd say try to get to market as quickly as possible, because having a minimum viable product, they call it an MVP, out there, at least you can start generating some revenue to then go improve. Like the very first Mosquito that we launched, it did what we said it did, but it wasn't nearly as good as the Mosquitoes that we're making now, because we've gone through numerous iterations since then of improving everything about the Hotend from beginning to end. Materials, process, coatings, all sorts of things. And that's true of any product when it launches. The first iPhone wasn't as good as the 14th iPhone. And then I'd say it costs virtually nothing to file a patent application and get patent pending. I would do that, get a pending patent. And then once you've done that, see if you can get a legal opinion for, a lot of patent lawyers will have an initial conversation with you for free, the free consultation. And yeah, so that's well worthwhile to have that initial consultation for free and just get their ideas, see what they think. Maybe they know a way that you can, get this done for $2,500 instead of $10,000 or whatever, So, yeah.
All right, cool. And I think we're about ready to wrap up, but I got to ask, what other cool products are on the horizon coming from Slice that you can share?
uh,
If you can't share, I get it,
yeah,
but
yeah. I can't share yet. We just launched two pretty big products for us that have been in the works for a long time. Mosquito Prime, of course, that we talked about. It's higher flow, Hotend than anything we've built before. Um, we also launched a new nozzle that we're pretty excited about. Has a true anti-adhesive coating on it. Good thermals, abrasion resistant. Does everything our previous nozzles did, but better and cheaper. So we're excited about that. It's called Gamma Master. And we're going to continue to do what we've done. We're going to keep trying to make stuff faster, keep experimenting with new coatings and stuff to improve performance. Yeah, so we're always trying to improve performance and make things more reliable, and that's what we're going to keep doing.
all right, cool. Well, Peyton sent me a couple of those Gamma Master nozzles, so I
Awesome.
think something I'll try to do is just like try and stick it into sticky plastic and see if
Sure.
it'll get stuck there.
Yeah.
But it probably shouldn't stick very well.
It shouldn't. No, there's a number of things that we use for testing these properties. The official one is called a dying test,
Okay.
but we also use a test that we call plastic pizza, which is kind of an absurd. But basically, we get a sample of the material or of some piece of steel, and then we'll put different coatings on it. Send it out to different coatings, and then we will bake different plastics onto it, and then try and measure how easy it is to remove or not remove. So that's one of the tests that we run for these like anti-adhesive properties.
All right. Well,
Yeah.
that sounds like a fun little test to run.
Yeah.
You got to call it like, I mean, the orange slice kind of looks like a pizza that's been cut up into
Does
pieces.
get that
So.
a lot. Yeah.
All right. Well, thanks for joining me today, Dan.
Thanks.
I'll leave links to Slice's website so you can go check out their products. And yeah, so that's about it. Thank you.
Thanks, Nathan. Appreciate you having me.